So it says example 3, but it's really our example 4. A rectangular page is to contain 24 square inches of print. The margins at the top of and the bottom of the page are 1.5 inches, and the margins on the left and right of are 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Okay, now the hardest thing about problems like this are picturing what they're asking. So we've got a piece of paper. Okay, it's a rectangular piece of paper, and inside the paper is the print area like this. Okay, so this section here is where the actual print will be. Now they told us the area of the section of print. The rectangular page is to contain 24 inches of print. Okay, so I'm going to call this side right here X. And I'm going to call this side up here Y, okay? And so the area of the printed section is X times Y, so we can write 24 equals X times Y. Okay? Now let's figure out the size of the entire page. Now it says right here that the distance from here to the top and from here to the bottom has to be how much? The margins at the top and bottom have to be 1.5 inches. So this distance here is 1.5 inches, and this distance here is 1.5 inches. So the overall length, okay, the overall length of the page right here is how much?
X plus 3.
Good, X plus 3, exactly. Okay, and then they said the side margins, the distance here was 1 inch, and the distance here was 1 inch. And so the entire bottom would be 1 inch plus 1 inch, which is 2 inches, plus Y. So we've got Y plus 2. So the area, because the question's asking us, what should the dimensions of the whole page be? What should the dimensions of the entire piece of paper be so that the least amount of paper is used? So we want to minimize our function once we get it. And so I've got my overall area of the page is X plus 3 times Y plus 2. That's our overall area of the page. Okay? But the problem is our function here is in terms of two different variables. I've got an X here and I've got a Y here. Right? And so what I can do is I can take the portion that they told me about the print section, and I could solve it for Y by dividing X on both sides. And so I'd have Y equals 24 over X. And then I could substitute what Y equals in for Y in our function. And so I'd have area equals X plus 3 times 24 over X plus 2, like that. Okay, so now what we need to do is we need to FOIL these two binomials. And so to do that, what I'm going to do is multiply X times 24 over X. And so I have that my area equals just 24. And X times 2 is 2X. And 3 times 24 over X is what? 72 over X. Plus 6, because 3 times 2 is 6. Alright, so I've got area equals 24 and 6 is 30, plus 2X, plus 72. I'm going to write this as 72 times X to the negative 1 power, so that I can differentiate. So there's my area function. I want to minimize this. So I'm going to take the derivative. A prime equals, the derivative of 30 is 0, the derivative of 2x is 2, and the derivative of 72x to the negative 1 is negative 72x to the negative 2 power. I'm going to rewrite my derivative as a prime equals 2 minus 72 over x squared. Okay, and now I need to minimize it. Now, you can immediately see that 0 will make your derivative undefined. So 0 is going to be a critical number. So my first critical number is x equals 0. And now I want to take this function right here and I want to set it equal to 0, right?
Yes.
So I've got 2 minus 72 over x squared equals 0. Okay, now there's a lot of things you can do here. One of them is you could subtract 2 on both sides. And so you'd have negative 72 over x squared equals negative 2 over 1. And now I could cross multiply. So I'd have negative 72 equals negative 2x squared. And now I'll divide by negative 2 on both sides. And so I get x squared equals what? I think it should be, yeah, positive 36. Now, when I square root both sides, I get that x equals plus or minus 6. But now, the minus 6 doesn't really matter because I know I'm not going to get a length of paper that's negative, right? So really, I only have to look at the positive 6. Okay, so our critical numbers are x equals 0 and x equals 6. We eliminated negative 6 because we're not going to have a length of paper that's negative. And we also are not going to have a length of paper that's 0. If the length of our paper were 0, we wouldn't have any paper. Okay? And so I'm going to write my number line, and I'm going to confirm that 6 is in fact my length. Okay? But it's got to be my minimum, doesn't it? So I'm going to test to the left of 6. So I'm going to do f prime of 5 and f prime of 7. So when I plug 5 into the function, I get 25 on bottom. Okay? 72 divided by 25 is what? Alright, and so 72 over 25 is 2.88. And so 2 minus 2.88 will give you a negative. So it is decreasing. Let's plug 7 in. When you get plug 7 in, you have 72 over 49. What is 72 over 49 is 1.46. So 2 minus 1.46 will give you a positive number, so it is going up. And so indeed, there is a minimum at 6. Okay? And so what we want is we want x to equal 6. But now we need to go back to our original problem and figure out the rest of the dimensions of our piece of paper. So here is our original sketch of our piece of paper. Okay? And so I've got 24 equals xy. But now we know that x equals 6. And so I'm going to substitute it in for x right there. So I've got 24 equals 6y. And I'll divide 6 on both sides, and so y equals 4. And so now I know x and y. Okay? So my whole piece of paper, I'm going to plug 4 for y. So the dimensions are, on my piece of paper, the bottom of it, okay, should have been 6 units. And the length should have been 6 plus 3 units, which is 9. So 9 by 6 will produce us a piece of paper with 24 inches of square print, but it minimizes the size of the piece of paper. And so you can see it asks, what should the dimensions of the page be? It should be 9 by 6. And that minimizes the amount of paper that needs to be used.